Well, this is where the rubber meets the road. This is where we get into grade 11 and grade 12 trig. Okay? It's going to be continually using the stuff that we've already learned, but this is where we're heading with this. Once we're done with this, we can move on to the other half of this trig unit and deal with the sine law and the cosine law and some other things. So I want you to pay careful attention to my objectives today. Find trigonometric ratios for rotation angles if I give you the right information. That is example 1. I say that because there's a whole bunch of different types of examples we're going to be doing today. And later on, when you look at your assignment, there'll be questions that will say, do this, it's like example 1. Do this, it's like example 2. It will help you out. We're going to be finding trigonometric ratios if I give you the angle, and it's a special angle. And we're also going to be finding missing trigonometric ratios if I give you one trigonometric ratio and enough information. So to begin with, we have to retool everything we know about sine, cosine, and tangent. Because as I mentioned the other day, when we rotate that terminal arm around and we get past quadrant 1, you no longer have a triangle to look at. The concept of opposite and adjacent and hypotenuse goes out the window. So, number 1 has a warm-up in number 1 that says we have a rotation angle that's in quadrant 1. And I'm just putting in bold. Notice the rotation angle and the reference angle are the same. How can the distance r, which is, if you look at the diagram, the distance from the origin to that point, how can that be found if I knew the coordinates of that point? If I told you that point was at 3, 4, how could we find that length to point P? If I told you that point was at 5, 40, how could we use those numbers to find the length, which we're going to call R? Do you know? No?
Would you use Pythagoras?
Sure, we could use the Pythagorean theorem because what we have is a right angle triangle here. Here's my right angle triangle. R is the hypotenuse. The base of this is x, and the height is y. So it turns out that x squared plus y squared will equal r squared. It's the Pythagorean theorem. I don't think we need to explain with words. I think this is good enough. That's how we could find r if we knew x and y. Okay, write an expression for each of the following. Well, I'm not asking you to go back to grade 10 and write opposite over hypotenuse. I want you to look at that diagram and tell me what sine is equal to on that diagram. Sine of theta will be the opposite over the hypotenuse, but the opposite is y, and the hypotenuse is r. So, you know how in the past when we talk about triangles we say sine is opposite over hypotenuse? From now on, no matter which quadrant it's in, we're going to be saying on the coordinate grid, sine is y over r. Who's in physics 20 with me right now? Show hands. That is why when you take the cosine of the rotation angle in RCS times the vector, you get the x coordinate. But when you take the sine of the rotation angle times the vector, you get the y coordinate. R is the length of the vector. Everybody else just, I don't know what was just said. That's fine. What would cosine of the rotation angle be? Well, you look at this, you say cosine is normally x, or normally adjacent rather, but on here it's x, and the hypotenuse is r, so it's x over r. And tangent is opposite over adjacent. Looking at this diagram, that would be y over x. So what you do from now on, and there's more to it, we're not just going to dive right in, but is instead of thinking opposite, you're always thinking y. Instead of thinking adjacent, you're always thinking x. And the hypotenuse is out the window. The hypotenuse is the distance from the origin to the point you're talking about, no matter where that point is, and that's called r. So what is true about the nature of the positiveness or negativeness of the three trig ratios in quadrant 1? Well, I want to go back and address something. And this is not a simple lesson. It requires thought as well as learning specific things. Would you agree that in quadrant 1, x is always positive? Is y always positive in quadrant 1? Yes. Pay very careful attention to what I'm about to tell you. R is always positive. I don't care where it is, because I've told you r is the distance from the origin to that point. So r is always positive. What I've established is in quadrant 1, x and y are positive and r is always positive. So what that means, everybody, is that in quadrant 1, y and r are both positive, so sine will always be positive in quadrant 1. Always. If you take your calculator and take any angle that's bigger than 0 degrees and less than 90 degrees, and you go sine of that angle, you're going to get a positive answer. Okay? So, sine of theta in quadrant 1 is greater than 0. That means it's positive. Cosine of theta in quadrant 1 is greater than 0. It's positive. Why? I mean, how come? Because cosine of theta is x over r, and in quadrant 1, x is positive. And r is always positive. Tangent of theta in quadrant 1 is always positive. Just briefly here, it doesn't matter which number I use. I'm going to take the sine of 85.25 degrees. I get a positive number. I'm going to take the cosine of 55 degrees, positive. I'm going to take the tangent of 65.8 degrees, positive. Don't worry about what the numbers are. That's not important. I'm always going to get positive. 2. Warm-up 2. Sketch a rotation angle in standard position whose terminal arm is located in quadrant 2. Okay? I don't care where you draw it. It's got to be in quadrant 2, though. Right? I mean, I care where you draw it, but I don't care what the exact angle is. I want you to notice here that this is theta, but the question says use the reference triangle. What does that mean? Well, first of all, we have to put a point on here. The point is at x comma y. X happens to be negative, but it's still at x comma y. The reference triangle is this triangle because it contains the reference angle. It's saying use the reference triangle to write expressions for sine, cosine, and tangent. Well, everybody, this distance, and I don't want to add too much to the diagram, so I will just verbally tell you, this distance is still y. And this distance is still x. Except that x is a negative distance, right? If that distance that I've highlighted in blue is 5, that means the x-coordinate is actually -5. We have to broaden our horizons here about what distance means. It's a negative distance. It's like a vector for you Physics 20 people. Okay? So when I look at this reference triangle, what is opposite the reference angle? Y. What is the hypotenuse? This is still called r. R is the distance from the origin to the point. And what that means is what we learned in the previous warm-up is the same here. Sine is y over r. Sine is going to be y over r no matter which quadrant we're in. Cosine is the adjacent side, which is x, divided by the hypotenuse, which is r. And tangent is the opposite side, which is y, divided by the adjacent side, which is x. So here's where I can't really explain. I don't think I can satisfy everybody with this explanation, 100%. But these thetas here, when we say sine of theta is y over r, I am still talking about the rotation angle. It's just that I use the reference angle to define what it's going to be. So this isn't sine of the reference angle, it's sine of the rotation angle. What can we determine? I don't think I have that. Can I just see your notes here? See, I'm going to add one more thing. What can you tell me about the positiveness or the negativeness of each of these if the rotation angle is in quadrant 2? Help me out here.
Sine would be positive, but cosine...
Can I stop you there for a second? Sine would be positive. Can you tell us why you know in quadrant 2 sine is positive?
Because y and r would be positive.
Right. And where is r negative?
Never.
Never. R is always positive. But Claire's saying in quadrant 2 y is positive. You can see up here at the point I've indicated y is positive. Continue, please.
Cosine and tan would be negative.
Okay, let's start with cosine. Cosine of theta will be negative. Can you explain? Maybe I'll do this. Can you explain why cosine of a rotation angle in quadrant 2 is negative?
Because x would be negative, but r is still positive, and when you divide or multiply by a negative and positive number, it will always be negative.
Right. Negative divided by positive is negative. And if you look at the diagram in quadrant 2, this is grade 6 or 7, I don't know what math. Over here, you don't call it quadrant 2 in those grades, but you know x is negative over there. And then
Tan would be negative.
tan would be negative. And just finish our thoughts here, Claire.
X would be negative still, and y is positive in quadrant 2, and when you divide or multiply by a positive and negative number, it will always be negative.
Positive divided by negative is negative. So I would like everybody to pick your own personal number that you know is in quadrant 2. It has to be greater than 90 degrees and less than 180. And I would like you to take the sine of that angle and confirm that you get a positive. If you're having trouble finding an angle, use 120. 120 degrees is in there. You do need to make sure, of course, you're in degrees. Just double check, because your calculator can do funny things. I'll use 124 degrees. Whoops. I want the sine of 124. Well, 124 is in quadrant 2, and in quadrant 2, y is positive, r is always positive. I get a positive ratio. If I take the cosine of 124, boom, I get a negative. Why? Because as soon as I pass that vertical y equals, that vertical 90-degree position to get into quadrant 2, y becomes negative, or x becomes negative, rather. Let me repeat that because I bumbled my explanation there. In quadrant 2, x is negative. Cosine is related to x. It's x over r. So in quadrant 2, cosine will be negative. As Claire said, in quadrant 2, x is negative but y is positive. If tangent is y over x, then you would have a positive divided by a negative, which would be a negative. And again, we don't want to worry about what the numbers mean. We're building up to this eventually. Now, we could extend this to quadrants 3 and 4, but I'm not going to. I would rather you think about this, and I'm just going to indicate up here that here is quadrant 3. You should be able to figure out that x and y are both negative there, which means cosine will be negative because x is negative. Sine will be negative because y is negative. But tangent's going to be positive because tangent's y over x, and they're both negative. Notice when I talked about cosine being negative, I said it's negative because x is negative. R is always positive, so I don't even need to think about R. Over here, where I'm indicating with my arm in quadrant 4, x is positive and y is negative. That means cosine is positive here, because cosine is related to x. Sine is negative here, because sine is related to y. And tangent will be negative because it's y over x, and one's positive and one's negative. Back when the Earth was still cooling and I was in high school, we had a rule called the cast rule. I think it's the dumbest thing that people have come up with, one of the dumbest things in high school math, because it's spelled cast, but you don't start in quadrant 1. What this means is that the only thing positive in this quadrant is cosine. They are all positive in this quadrant. The only thing positive in this quadrant is sine. Shouldn't say the dumbest thing. It's just that it doesn't match with the quadrants, right? You start in quadrant 4. And then the only thing positive in this quadrant is tangent. Personally, I don't even think you need a rule. I would rather you just say sine is y over r. Is y positive or negative where you're looking? If you do want the cast rule, there it is. I don't know who came up with this. You can start with quadrant 1 and say add sugar to coffee. But again, I think it's better if you just understand what's going on here. What I'm telling you is you need to know for what we're about to do, everybody. If I look at quadrant 2, you need to know, is sine positive or negative? Is cosine positive or negative? Is tangent positive or negative? You need to know this set of facts. All right. In every case, so now you're just watching here. We don't have to write anything for a while. In every case, it's the x coordinate that we associate with adjacent, the y coordinate that we associate with opposite, and r becomes the hypotenuse. Nope. It doesn't matter. Both the x and y coordinates can either be positive or negative depending on the quadrant, but the distance r is always positive. So there's more details on page 90, although I would think, my advice is, I think if you look at page 90, it might be a little confusing. They do something, I don't want to get into it, but I think their diagrams are a little, how their diagrams are labeled is a little weird. And I know I'd probably pique your curiosity, you want to look, but I'm saying if you look at page 90, they have all 4 quadrants, but there's something about the way they've done it that I disagree with. Okay. So in quadrant 1, and I've changed this. This is the textbook diagrams from page 90, but I've changed it so it's better. This is what quadrant 1 looks like. I'm recording this lesson, so if you want to look at these diagrams in detail later, the link will be in Google Classroom. R is always positive, x is positive, y is positive. Quadrant 2, R is always positive, y is positive, x is negative. I'm really, you know what I'm giving you is stuff that you should know already. Right? You should know this. In quadrant 3, that's the rotation angle in red. X is negative, y is negative, r is always positive. And in quadrant 4, y is negative, but x is positive. Any questions before we move on? All right. Can you just take this in? Just soak this in. Look familiar? It's from your formula sheet from Math 10C. It's what you use when you talk about triangles. Gone. This is what we use when we talk about coordinate trig. This is what's on your formula sheet when you look under trigonometry. You don't see opposite, adjacent, and hypotenuse. You see all this stuff instead. So you don't need to memorize this, but boy, I hope you're not going to go to your formula sheet every time to know cosine is x over r. All right, let's get to it. Examples. The point 5, 12 lies on the terminal arm of a rotation angle. What's the exact value of sine of theta? The biggest mistake people can make is think you have to find theta. I'm not asking you for theta. I'm asking you for the sine of the rotation angle. We don't need to draw this. We do not need to draw this rotation angle. I will in a minute, but sine is y over r. Cos is x over r. Tan is y over x. What is it exactly that we're missing in this question that's preventing us from telling you what sine of the angle is?
R?
We don't know r. But x squared plus y squared equals r squared. Right? The Pythagorean theorem says x squared plus y squared equals r squared. So that means 5 squared plus 12 squared is r squared. R squared is 169 if my math is right. And the square root of 169 is a nice round 13. Yep. So r is 13. Well, then sine of the rotation angle is 12/13. Cosine is 5/13. Tangent is 12/5. Because this is x and this is y. And I have to be honest with you up front. Sometimes I think students don't need to know the rationale for things. But I'm going to tell you right now, don't worry about what this means, because in the past I've spent time explaining what this means at this point, and people forget what it is they're supposed to be doing. We'll worry about the deeper meaning of this when we need to. Basically what it means is if you knew the angle and you took the sine of that angle on your calculator, you're going to get that number. Okay? I'm just going to show this to you briefly. And I do not want you to worry about what I'm doing on my calculator at all. I'm going to hide my calculator from view for you for just a minute. Nope. Okay, so I'm going to tell you that what I have stored in A, in my calculator, in slot A, is the rotation angle, okay? I'm going to tell you that I know how to find the rotation angle, but I don't want you to worry about it or think about how I did it. This is the rotation angle, okay? Turns out that's the rotation angle. I'm going to take the tangent of that. I get 2.4. Oop. Yep, 2.4. What's 12 divided by 5? 2.4. I'm going to take the cosine of that. 0.991222830. Wait, have I got it backwards? Just a second here. Just a second. Hang on. Got a mistake here. What did I do?
Did you take the cosine of 2.4 or 67?
Thank you. I knew I did something wrong here because I'm supposed to get 5/13. That was going to be my point. And I had one of these moments where I thought, geez, did I just turn the universe inside out on itself? Did I discover something that I wasn't supposed to see? Thank you. When I take the cosine of that angle, I get this number. What is 5 divided by 13? That number. When I take the sine of that angle, I get 0.9230. That's 12 over 13. That's what it means. Okay? Let's move on. The point negative 8 comma 15 lies on the terminal arm. What's the exact value of each of the following? Well, look, sine of theta is y over r, so it's going to be 15 over r. Cos of theta is x over r. It's going to be negative 8 over r. Tangent, watch carefully what I'll write it out first, is y over x. Are you with me on the y over x thing? Okay, tangent of theta is negative 15/8. I despise having a negative in a denominator of a fraction. Okay, I think it's even worse when you see this in your textbook. You can't count the number of times people go, I'm getting a negative and it's not in the back because they put that negative so close to the fractional line. I would prefer the negative on top. I just want everybody to know when I say tangent of theta is negative 15 over 8, I'm not saying y is negative 15. I'm saying y over x is negative 15 over 8. So what are we missing? R. How do we find r? X squared plus y squared equals r squared. So negative 8 quantity squared plus 15 squared equals r squared. Personally, if I'm using my calculator to figure out what the sum of these squares is, I wouldn't even put the negative in because I know when I square it, it goes away. Is that 289? So r squared is 289, which means r is the square root of 289. Is that a perfect square? It is? What is it? What is it? 17. So we're done. Over 17, we're done. It's not difficult. You just have to warp your mind into understanding that it's not opposite, adjacent, and hypotenuse right now. If you had a triangle, you could do that, but we don't. Determine the exact value of the sine of 240 degrees. Okay. I mean, I can tell you that the exact value of the sine of 240 degrees is negative root 3 over 2. And there's a reason for that. Because if I sketch 240 degrees, and you'll notice that didn't just come out of my mouth. I was thinking of it. I was forming this sketch in my head. And I know that 240 degrees is a reference angle of 60 degrees. Well, you should know that too, right? 180 plus 60 more. So that means our reference triangle is this. And sine is y over r, right? You know this triangle. This is 2. This is 1. And this is root 3. Except it's negative root 3. Because it's a y value that's negative. So all we're doing is taking that triangle from yesterday and we're putting it on here. And we're saying the y coordinate is negative root 3, right? This is our point right here. The y coordinate is negative root 3. The length of r is 2. Sine is y over r. Go ahead, just take your calculator, take the sine of 240 degrees. Now take negative 1 times the square root of 3, close brackets, divided by 2.
Negative 1.
Same thing.
Could you repeat that?
Pardon me?
Could you repeat that?
Sure. What I'm asking you to do is figure out what this is, and what you need to do to enter that on your calculator is go negative, I said -1 times the square root of 3. You don't need to put a 1 there. The other thing I added, Claire, was close brackets or end brackets, because you don't want to take the square root of 3 halves. You just want to take the square root of 3 divided by 2. And this is the same thing that you get if you find the sine of 240. Whoops. Yeah, I saw what I did there. So what is the exact value of cos 315? I would like everybody to just think, and you can use your calculator here, which quadrant is this terminal arm in, and what reference angle will it contain? Joseph?
The 45-degree triangle.
In which quadrant?
Fourth.
4, right? So 315 degrees. You'll notice that basically what I've done now is I've upped the ante and said, I'm not going to explain this every time. 315 degrees will land you in quadrant 4 with a reference angle of 45 degrees. That means you are looking at this triangle. Notice the triangle always uses the x-axis as one side, because the reference angle is with respect to the x-axis. This is 2. Each of these are root 2, except one of these is not actually root 2. One of them is negative root 2. That's right, Keegan. This one's negative root 2 because it's a negative y. It's positive x. And by the way, I'm sorry, maybe I should back up. This one here is negative as well. This is a -1. I didn't pay attention to that because I knew I was after y over r, and that's x. So what is cosine? Cosine is x over r. Well, the opposite happened here. We don't really care about the negative root 2 because cosine has nothing to do with y. All right? As I said, this is an action-packed lesson. Number 3. Things take a bit of a turn here. So you're told, 3a is pretty tame, that cosine of theta is 9 over 41, and you're asked to find sine of theta and tan of theta. So, can I say the following? Can I say that x is 9 and r is 41? Sure, because cosine is x over r, right? This is x over r. A few of you are going to stumble on this question in your head, so I'm just going to address it now. Could you say x is 90 and r is 410? Yes. Could you say x is 18 and r is 82? Yes, because it's a trigonometric ratio. It's a ratio of two numbers, and all that's important is the ratio is 9 over 41. So if I double 9 and double 41 to get 18 and 82, this is still going to divide to give 9 over 41. But I think the most reasonable thing to do is that. I just point that out because sooner or later somebody's going to go, well, how do we know that arm goes all the way to an x-coordinate of 9? Well, we don't. But if it does, the length of the arm will be 41. If it goes to 18, the length of the arm will be twice as great. So what are we missing here? Sine is y over r. Tangent is y over x. I think it's pretty clear that our mathematical lives this afternoon would be complete if we knew y. How do we find y? Pythagorean theorem. Put in the numbers. I like brackets around numbers. 9 squared plus y squared equals 41 squared. I know you guys have used the Pythagorean theorem for years, but sometimes, just to remind you, sometimes we add the squares together and then take the square root. Sometimes we subtract the squares, then take the square root. When you're finding the hypotenuse, you add them. When you're finding a leg, which is a non-hypotenuse, you subtract. So I need to take 441 squared minus 9 squared. And I have no idea. Geez, you know, I believe I just said 441 squared, and I don't know why I did that. You have to take 41 squared and subtract 9 squared. Can you tell me what you get, Abby? Before you square root.
1,681.
A little louder.
1,681.
1,000.
1681.
1681, thank you. That's my fault because I have bad hearing. 1681. Y squared equals 16. Is that a perfect square? When you take the square root of it, what do you get? Ben? No? Is that not what you, go ahead.
You forgot to subtract 9 squared.
Okay. Okay. So, oh, and you misunderstood. That's okay. That's my fault. I should have been clearer. What do you get for y squared, meaning the 41 squared minus the 81? You get 1,600. Okay, good. And 1,600 is certainly a perfect square. It's the square root of 40. So then you say y equals root 1,600. You get y equals 40. I'm right, aren't I? 40? You put the 40 here. You say 40 over r, which was 41. And y 41 over r is 9. Good? And you all get the question wrong.
It's sine and tan are negative.
Don't. No. I'm asking you to think. I don't want people shouting out answers, please. Neither one of those answers that I've written are correct. And this is something that I've mentioned briefly before, but we're going to really focus on later in the course. When we say that 40 equals y, we're saying that because when you square 40, you get 1,600. But there's another number that you can square that will also give you 1,600. Negative 40. Right? If I say to you, solve this equation, and you say, well, y equals 3, I would say to you, why can't y be negative 3? 3 squared gives you 9, and negative 3 quantity squared also gives you 9. So down here, when we take, from now on, everybody, when we take square roots, have I shown you that notation? I have. We need to say, whenever we introduce a square root, we go plus or minus. Okay. So that means plus or minus. And that literally means, and we talked about this in physics, right, with the VF. That literally means y is equal to 40 or y is equal to negative 40. And I'm going to tell you right now that in this question, one of those is correct, and it's the negative 40. But the 40 is not. Who can tell me why it's negative 40? Right. And I purposefully didn't say that when I read this question. I just ignored that. I didn't want to draw attention to it. But it does say it's in quadrant 4. And in quadrant 4, y is negative. So that means and I wrote 41 here. I meant to write 40. That means that those are the values. I believe we have one more. Are you still with me? There's just one more. It's a real quick one, but this is the wrinkliest of the wrinkly. This is the one that I'll put on an exam and it will catch a lot of people. So tangent of theta is equal to 8 over 3. You're asked to find sine of theta, which is y over r. You're asked to find cosine of theta, which is x over r. Is that a fair assessment of this question? Okay. So you know that tangent of theta is y over x. And that means y equals 8, x equals 3, and to find r, use the Pythagorean theorem. And it's wrong. Because y can't be 8 because it's in quadrant 3. That's what you were going to say, right? And x can't be 3 because it's in quadrant 3. In quadrant 3, they're both negative. And that explains why we don't see the negatives, because it's y over x. It's negative over negative. You would never see the negatives. We wouldn't write negative 8 over negative 3. We'd just say, well, that's 8 over 3. So as Owen was going to point out to me, no, it's not correct. These are both negative. And what that means is when you go over here, if you just put 8 over whatever r ends up being, and you just put 3 over whatever r ends up being, it will be wrong. And you know, forget about understanding math for a second. Sometimes, and you know this when you write an exam, your success is based on getting things right. Not, well, I really understand it, but I made a mistake. You made the mistake, you don't get the mark. It's wrong. So these are both negative. To find r, it's a very simple matter. I'm going to put in, bless you, I'm going to put in the negatives, although I wouldn't personally put them in if I used the Pythagorean theorem. I believe that's 73. Yes? So that means that r squared equals 73. That means r equals root 73. Would you agree? Would you agree, root 73? Okay. Okay, well, let's finish this. Let's put over root 73 for both of these and be done with it with one final parting comment. Mathematically, if I ask you to solve this equation, the solutions are plus or minus root 73. Mathematically, that's a fact, which means r is equal to root 73 or negative root 73. In the previous question, we threw out the positive root because of the quadrant it was in. Why are we going to throw out the negative root here? Claire?
Because r cannot be negative.
R is never negative. And I mention that because I will very rarely put plus or minus with the r. I'll just say it's root 73 because we all know r is positive. So this is what I meant earlier when I started the lesson. And I want you doing them in this order. I put them in this order so it matches the lesson, and I put the lesson in a particular order because I think it's easiest for students. The first one is going to be number 3 in your textbook, and it is simply finding x or y or r and writing out your 3 trig ratios. 2 is, I believe, where you're going to find the exact values of things like sine of 240 degrees. And then the rest of this is all just kind of a variety of different questions. You have a little less than 20 minutes here, which isn't bad for this lesson. I still have to get used to the fact that our days are now a little bit shorter because we're into that Sabre support thing, but you got about 20 minutes to work on these. In the words of my mother, pitter patter, let's get at her. You know, I would say this summarizes everything right here. Whether it's in quadrant 2, 3, 4, 1, I don't care. Let's get to work? Yeah,
May I use the washroom?
of course.